Okay, this is the last lecture on this series of lectures on matrix algebra for this course, and today. And now we speak about matrix differentiation. Okay, suppose, for example, that we have a model OLS, y is equal to x beta plus epsilon. And then Malene will show to you that you need to minimize the following function. Epsilon transpose epsilon is equal to y minus 2 beta prime x prime y plus beta prime x beta. And we need to minimize the following function with respect to beta. And then the problem now, or I think that you have never seen, how to differentiate respect to beta these elements. In particular, this one and this one. We call this one 1, and we call this part of the equation 2. And then we need to show you, and I need to show you what are the results. Okay. Given a vector A that is m by 1, and where we know what there is inside, and x m by 1 of unknowns, then the first result that we need for this part is this one, is the following, that the derivative of a prime x given the x is equal to the x prime a with respect to x, and this one is equal to a, where a is a1, a2, an. Super. The second, and then let's check here. The derivative of this guy with respect to beta it will be minus 2 x prime y. This is the result. The second result that we need is for 2, and let's suppose that we have x unknown and a symmetric m by n matrix. Then index 2 times ax. This is the result. Let's try to understand why this is the result. Suppose, for example, to have x, x1, x2, x3, and a is symmetric, then a11, a12, a13, a12 again because it's symmetric, a22, a23, here is a13 because it's symmetric, a23 because it's symmetric, and a33. You can show that if you calculate this quantity, x prime ax, given these two definitions, you obtain something like We can call this one f of x1, x2, and x3, and this one is equal to a11 x1 squared plus a22 x2 squared plus a33 x3 squared plus 2 a12 x1 x2 plus 2 a13 x1 x3 plus 2 times a23 x2 x3. And if we try to differentiate this equation with respect that we called fx1 x3, x1 x2 x3, with respect to vector x, then we get something like that. 2 times a11 x1 plus a12 x2 plus a13 x3. This is the first element. The second element of this vector is 2 a12 x1 plus a22 x2 plus a23 x3. And the third one is 2 a13 x1 plus a23 x2 plus a33 x3. And you can notice that this vector you can write like 2 times a x. 2 is a scalar. A is the matrix defined here, and x is the same. Okay, if you want, you can try, but this is the result, because you see that here there is a linear combination of aij's and xi's. Here are the same, and here the same, and then at the end you can write, you know, this system in this way. It's very simple to prove. Okay, the last thing that I want to show you is something that is related to the likelihood function, because sometimes we need to take the score or the derivative respect some parameters. Then the application of what I'm doing now is the likelihood. A likelihood function is a function f of theta, where theta is a vector that takes values in Rn and goes to R, then takes m values, and as output it spits out one number. And we need to define this quantity, d theta. And this one is called the gradient. And this one is a vector that is a m by 1, where we take df d theta 1 as the first component, df d theta 2 the second component, blah blah blah, till df to d theta n, because theta, this theta we said that is theta 1, theta 2, theta n is a m by 1 vector. Okay, the last thing that we need to know is the Hessian. What is the Hessian? Is the second derivative of this likelihood function, and it's something like the f the theta prime, and this is a m by n matrix, and it's done like that. We have the second derivative of f with respect theta 1 2 times as the first element. The second element is d theta 1, d theta 2, blah, blah, blah. And the last one is d theta 1, d theta n. Okay. Here there is d squared a, there is the second derivative of f with respect to theta 2 and theta 1, d squared f d theta 2 squared, blah, 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 d squared f of d theta 2, d theta n, blah, 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 blah. At the end we get the second derivative of f with respect theta n, theta 1, f d theta n, d theta 2, d square f d theta n, d theta n. Look that this is called the Hessian matrix, and this is a symmetric matrix. Now, theta also in this case is an n/1 vector, that is theta 1, theta 2, theta n. Okay. Okay, with these results, I think that we have finished all the lectures, and I hope that these lectures were, very useful for you in order to understand all the concepts and all the contents that Malene explained to you, and I hope to see you in class sometimes. Bye.